Hello, and welcome to Chapter 6, Section 3. We are now looking at confidence intervals for population proportions, meaning in these problems we're going to be given a proportion of some sort instead of the means that we were dealing with in the last two sections. So in these problems we're trying to use a proportion from a sample to estimate what the proportion would be for the whole population. So sometimes in the problem, the sample proportion will be given to you as a percent. Sometimes you have to figure out, like from a fraction that they give you, what the percent would be. So we use this sample proportion as something called the point estimate for P. When we talk about this point estimate, we're going to use this symbol right here, P with a little like arrow on top. We read it as P hat. So P hat is going to stand for our sample proportion. It's always given as a percent or as a fraction. To find the fraction, so sometimes in the problem they'll tell you like this many people out of this many total were in our sample and answered the survey like this or something like that. So we're going to set up a fraction and then turn it into a decimal. So even if they give it to you as a percent, you're going to turn it into a decimal. We're always going to round to 3 decimal places for this class for our p hat. So our formula to find the confidence interval looks like this. So we have the p hat, so that's our point estimate. P hat plus or minus, we're back to ZC, just like in section 1. So ZC times the square root of p hat times q hat over n. So q we have used before. It was like the probability of failure. You just find it by doing 1 minus p. So whatever you get for your p hat when we found the point estimate, rounded to 3 decimal places, 1 minus that will give you q hat. And then multiply them together, divide by your sample size, and then square root the whole thing. So that'll be our formula for the confidence interval. So let's do an example. We've got a survey of 1,000 U.S. adults. 662 said it is acceptable to check personal email while at work. So right there, they've given us like how many people took the survey and how many people answered a certain way. So that would be our sample proportion right there, because they told us how big the sample was and then how many people said it was acceptable to check personal email while at work. So our p hat, our sample proportion, is going to be found by doing 662 divided by 1,000, because it was like 662 as like our desired number, and then 1,000 is the total number in the sample. Alright, so once I've divided, I get 0.662 for my p hat, which means 1 minus 0.662 is going to give me my q hat of 0.338. In this problem, we're looking for a 95% confidence interval, so my confidence level is 0.95. And then to find the ZC, we're putting that 0.95 in the middle of the normal curve, and then figuring out what area is to the left of it. So that'll give me a z-score, a positive z-score of 1.96. Alright, so we have all our information then to fill in our formula for the confidence interval. Let's do it. Alright, so here's my formula, and I filled in my 0.662 for the p hat, 1.96 for the ZC, and then on top I have the 0.662 times the 0.338 for the p hat times q hat, all divided by 1,000 for n. So in the calculator, we are typing in, I think the hardest part will just be the square root part of it. So in the calculator, I type it in like this. So I have the 0.662, and then I'm just going to do the subtraction one first. Minus 1.960, square root, and then like the non-updated versions of the calculators give you a parentheses first. So then I add in a second parentheses to do the 0.662 times 0.338. End that parentheses, because that's all the stuff on top, divide it by 1,000, and then end that parentheses that like match the one that from the beginning. And that should give you the correct number of 0.633. And then you do the same thing, but this time you plus, and you get the 0.691 as the other number in your range for your confidence interval. So basically what we're saying for this problem is we think that for the entire population of all U.S. adults, around 63.3% to 69.1% are the actual percentage of people who say that it's acceptable to check personal email while at work. Alright, so next type of question that we want to be able to do is the solve for n problems that we did back in section 1. Just, this time because we're dealing with proportions, the algebra is going to be slightly different, but we're setting it up like pretty much the same way. So let's say you're trying to run a political campaign and wish to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. So remember, just like before, we're looking for that word within, and then whatever number comes after it, that's what our margin of error is going to be set as. Find the minimum sample size, so solve for n, needed if a preliminary estimate gives p hat equals 0.31. So they're telling us what p hat to use. We're trying to use that margin of error formula and setting it equal to 3%. Alright, so remember our margin of error formula is everything after the plus or minus in our confidence interval formula. So like just this part, just that part is the margin of error. So then we need to figure out our ZC. P hat they told us was 0.31, so that means we can find Q hat by doing 1 minus 0.31, and then we're solving for n. Alright, so I figured out my ZC for 95% confidence. I get a Z-score of 1.96 multiplied by everything else plugged in. So our first step here, if we're trying to get n by itself, is to divide both sides by the 1.96. Alright, so once I divide that in the calculator, I guess in long decimal of like 0.0153 ... But then on the other side, I just have my square root left. So to get n by itself now, we want to get rid of the square root. So I'm going to square both sides. Alright, once I do that in the calculator, I get some crazy decimals, like 2 point something, but then there's -4 at the very end of it. I'm just going to write it as ... because this is like a really small decimal. But from here, we're trying to get n by itself again, but it's at the bottom of a fraction, so the easiest way to do this is to multiply both sides by n so that we no longer have a fraction. And then, so from here, to get n by itself, I just want to divide by that crazy number. So in my calculator, I'm going to do the 0.31 times 0.69, all in its own parentheses, divided by the second answer of like, the copy-pasted version of that crazy number. Alright, once I do that, I end up with 913.02, more decimals, whatever. But it doesn't matter because, remember, n is a sample size, so we always round up. So our final answer is going to be 914. There we go. It doesn't matter what the decimal is, you always round up because we're saying we need at least 913.02 people. But we can't have 0.02, so we round up because it still needs to be more than this number. Alright, so that's the general process for solving for n. One other type of problem you'll see is where in the problem, instead of giving you p hat, they're going to say find the minimum sample size needed if no preliminary estimate is available. Because sometimes that happens when you're doing a survey or whatever and you have no idea what p hat's going to be, like you haven't even done that part of the survey yet. Then in that case, if we're just trying to guess like how many people we would need in our sample, like to figure out what kind of survey we can do, then we wouldn't have a preliminary estimate. So if this ever happens, then we're always going to use p hat equals 0.5. Alright, so in this case, if p hat is 0.5, then q hat's also going to be 0.5. Alright, so from here, the formula and plugging in and everything is going to be similar to before. So I have the same ZC because it's still 95% confidence. Instead of p hat and q hat of whatever numbers from before, now I have the 0.5s. So steps are the same. We're going to divide both sides by 1.96 first. I get some decimal. I think it was like 0.015 ... whatever. Square both sides to get rid of the square root. And that'll give me the 0.5 times 0.5 over n equals whatever crazy decimal. And then multiply both sides by n, divide by the crazy decimal to get n by itself. We end up with 1,067.11, so round up as usual to 1,068. And that would be it. So that's it for this section. Hope that helped. Don't forget to like and subscribe. Bye.